doing? Good day, pre-algebra. We kick off Advent with a new objective, a new unit, last unit of the binder, unit 4. And it's all about percentages. And so we're going to start by talking about what percentages are, and then do some conversion between decimals, fractions, and percentages. Because like we saw all the way back in, what was it, CO2? Something like that. Decimals and fractions are very much related. Well, the third piece of that puzzle is percentages. Okay, if we have the decimal 0.5, what is 0.5 as a fraction? Just kind of going back to CO2 or CO3 or whatever it is. Yeah. I'm not asking for percentages here, but what is 0.5 as a fraction, Nolan? 50 over 100, which reduces to be 1/2. Okay, but I'll write 50 over 100. And really that's like 0.50, right? We didn't have to write it, but and then what is this as a percentage? 0.50, 50 over 100. What is it as a percentage? Anthony? 50%. Okay, you can see that connection here, right? We got 0.50, 50 over 100, 50%. They're all related. Okay, they're all related. And so we're going to focus first on going from the decimal to the percentage. And today might actually be a double objective day, maybe going from percentage to decimal as well. Okay, but anyway, introduction. It says the first part of this is going to focus on relationships between decimals, fractions, and percentages. As it turns out, they're all related. And it's important to know how to convert from one to another because different data sets may use one of the three forms more than the others. Remember that percentages are out of 100. Okay, 0% is nothing. 100% is everything, right? Are there times when you can get more than 100%? Yeah, such as what? Is greater than 100%. What would be an example of when you could get that, or when that would make sense? Extra credit on a test, right? Some of you in your grade right now have above 100% because you've gotten everything plus some extra credit. The one phrase you've probably heard before is give 110%, right? That means like give more than you actually can give, which seems kind of contradictory, but whatever. Okay, but percentages are typically from 0% to 100%. And so we're going to divide this line here into tenths. So way over here on the left is 0, which represents our 0%. We'll put that up on top. And way over here on the right, what number would represent 100%? If 0 represents 0%, what number represents 100%? 100% means you have all of something. You have everything. You have the whole, all of it. Nolan. Not 100. One. Okay? One whole is equal to 100%. 0 is equivalent to 0%. One whole is equal to 100%. And think about that. Like a test score that would represent 100% would be like 25 out of 25, right? You see that, you're really happy, you got 100%. What is 25 25ths equal to? 100%. One whole, right? Anything divided by itself equals 1. 25 divided by 25 equals 1. 10 out of 10, 10 over 10 equals 1, right? So the reason why 100% is equivalent to 1 and not 100 is because to get 100%, you have something over itself, which as we know from division before, anything divided by itself is equal to 1. You have one whole, okay? So we're going to divide this into tenths here. And so I want you to kind of divide it into half first, okay? Put our 0.50 there. And now we're going to divide this into 10, 20, 30, 40, and 50. So 0.10, 0.20, 0.30, 0.40, and then our 0.50. It can be easier to divide into half first, rather than divide the whole thing into tenths at the same time. And now the second half of it, 0.6, 0.7, 0.8, 0.9, and then 1 whole. So 0.60, 0.70, 0.80, 0.90, and then 1, which if you want to write it as 1.00, you can do that, right? There's that kind of 100 that pops up there. It's 1.00. And so now it says, identify where 30% is. Where is 30% going to be on this number line? 30%. What decimal value will 30% have? Nolan? 0.3 or 0.30, right? Okay. If we're dividing this line up into tenths, it's kind of like we're dividing it up into 10% increments. 0.10 is 10%, 0.20 is 20%, 0.30, there's our 30%, so on and so forth. 0.65. 0.65. Where would that be on the number line? Between what two decimals would 0.65 be? Peyton?
60 and 70.
It's going to be between 0.6 and 0.7, right? Here's 0.65. And what percentage would that be? 0.65. Lily? 65%, right? If this is 60% and this is 70%, 0.65 is going to be right in the middle there. It's going to be 65%. Okay? How about 99%? Go ahead and mark 99% on your own, on your number line. Where's 99% going to be? Is it way on the left, or way on the right, or kind of in the middle? 99%. Mia? Way on the right, okay? 99% is going to be like right here. It's very close to 100%. You have almost everything. And what decimal value would 99% have? Nolan? 0.99. Yeah. Very, very close to 1 whole. Okay? That next one is 0.08. What percentage is 0.08? 0.08, yeah. 8%. Good. How is it different than 80%? Maybe in your head you were thinking 80%. How is 0.08? Why is it 8% and not 80%? Anthony? Right. That 8 is in the hundredths spot, right? If you were to read that as a price, it wouldn't be 80 cents. It wouldn't be 8 dimes, right? It'd be 8 pennies. 0.08. 80% looks like this. 0.80. We've got 0.08. So it's a subtle yet important difference there. 80% is very different than 8%. Okay, 0.08 is going to be right about here. And again, that's going to be 8%, not 80. 25%, give me a ballpark where that value is going to be. Mia? Okay, between 0.2 and 0.3. 0.25. Is the decimal value, and that's going to be 25%. Okay, 100%, that's way over here. That's everything, right? 1 whole would be the decimal value of that. And 0.82, what's that going to fall between? Gregory? Yeah, I mean closer to 0.8 than a 0.9. 0.82, and that's going to be 82%. Okay? Then we kind of get into this common mistake, because it does happen often, that difference between something like 0.9 and 0.09, right? Difference between 90% and 9%. Okay? And as Anthony brought up earlier, the key to look for here is what place value is that 9 in? Is it in the tenths place or the hundredths place? Because a decimal like 0.9, right, that 9 being in the tenths place, we can always add a 0 afterwards. Now it looks like 90%. Whereas 0.09, that 9 being in the hundredths place, right? Yeah, so let's talk about like 9 pennies, 9 hundredths. It's going to be 9%, right? So 0.7, 70% or 7%? Regan, 70%, okay? Because it's got that extra spot for that 0 there, 70%. 3% as a decimal, is it going to be 0.3 or 0.03? Gregory? 0.03. Okay, only 3%, 3 pennies, 0.03. 0.08, 80 or 8%, Ryan? 8%. That 8 is in the hundredths place. 0.1, 10% or 1%? Adrian? 10%, right? It's in the tenths place, 10 cents, 1 dime. You put the 0 there, 0.10, right? And finally, 60%, 0.6 or 0.06? Haven't heard from you yet today. Let's get a new contributor. Aiden, 0.6. And if you want to write that as 0.60, you certainly can, okay? But just that difference between that, 0.7 versus 0.07, 3% versus 30%, things like that. Are you seeing any connections here between going from a percentage, going from a decimal to a percentage? Any maybe tricks that you talked about last year, or any connections that you're seeing here? What's 0.22 as a percentage? Looking at the first one there under the Mr. Happy Pencil. What's 0.22 as a percentage? Mia? 22%. 0.3, we already kind of talked about this one. 0.3 as a percentage is 30%. And remember, it's because we can add that 0 there. 0.71 as a percentage. Lily? 71%. Someone impress me and your friends. What connections can you see here between going from a decimal to a percentage? Anthony?
You place the decimal 2 times it, right?
Essentially, yeah. Okay. That 0.22 to get to 22%, it's almost like we're just moving the decimal over to the right 2 spots. 22%. 0.3 or 0.30, move it over to the right 2 spots. 30%. Band? Or band, okay. 0.71, move that decimal over to the right 2 spots. 71%. Okay. So when you get to one that maybe you're not as familiar with, like 1.56, we can still use that little method, that little trick of moving that decimal over to the right 2 spots. What's our percentage going to be? Adrian? 156%. Right? Questions on this? Is it ringing a bell from last year? Yes. I'm going to give you 5 minutes to work on this page, and then it's going to be a double feature today, a second objective, 2 for the price of 1. But we will look at that after we have a chance to talk about this. So I'm going to pause the video. You can get to work, and then we'll discuss. And we're back. We did the first 3 together. We talked about the neat little trick of moving that decimal over to the right 2 spots. So everybody, 0.05 as a percentage. Thank you, everybody. 5%. 0.92. 92%. 0.2. 20%. Be careful you didn't put 2%, right? 2% would only be moving over once. Want to move over twice, and that extra number is a 0, 20%. 1.3. 130%, right? Move it over twice, 1, 2. Fill in an extra spot with a 0. 1.30 is above 100, so we know it's going to be above 100%, and it's like 1 and 30%, so 130%. 0.5, 50%. 0.21, 21%. 0.01, 1%. 1.81, 181%, 1.5, 150%. Stop me if I'm going too quickly. Are there any questions on what we've covered? I'm hearing similar voices give answers, right? But if you are not getting these correct and want to talk about it, now's a good time. Okay, 0.99. 99%. One whole. 100%, right? It's like that decimal is after the one. Okay, it's not written, so it's at the end of the number. And if we move it over twice, fill in those spots, we've got 100%. Also, we talked about one whole. You've got everything, 100% on a test or whatever it is. Okay, 100%. And 0.37, 37%. Good. Write a percentage between 1.66 and 1.69. What'd you come up with? A percentage between 1.66 and 1.69. Anthony, what'd you get?
I got 1.67.
So that would be a decimal between 1.66 and 1.69. What would the percentage value of that decimal be? Write a percentage between 1.66 and 1.69. You said 1.67, which is the correct decimal, but as a percentage. So what would 1.67 be as a percentage?
167%.
167%. Write a decimal between 84% and 85%. This one might be a little bit tricky, right? Because 84%, 0.84, 85%, 0.85. How do you come up with a decimal between those two values? They're right next to each other, right, Adrian?
84.5.
So 84.5, are you talking about like the percentage 84.5? Because the decimal 84.5 isn't between 0.84 and 0.85, right? But if we think about 84.5%, which is between 84% and 85%, what would that decimal be? Anyone come up with an answer for this that they're confident in? Yeah? Not 8.45. You're getting close.
0.84.5.
Well, you can't have two decimals in the same number.
Oh, wait. So 84.5.
84.5. Okay, the percentage 84.5% is between 84% and 85%. But if I have 84 cents and you've got 85 cents and someone says, well, I've got $84.50. 84.5 isn't between those two decimals, right? It's a very different decimal. It's 84 wholes, right? And then 0.5 after that. Here's where knowledge of decimals is very, very handy. What can we add on to the end of both 0.84 and 0.85 and not change the value? Mia, a zero. Can you give me a decimal that's between 0.840 and 0.850? Such as what? You can, Josie. So 0.8400 would be the same thing as 0.840, right? Because we're just adding zeros on to it. Kira? There we go. You were so with your 845, you're all very, very close, but the decimal would be 0.845, right? Because 845 is between 840 and 850. Okay, so there's the decimal value that's between 0.840 and 0.850. That knowledge of adding a zero to the end of a decimal, very, very handy, and we see it here. Those that said 84.5%, I'll write it bigger here. Okay? Spot on, right? We're going to talk about this in about a minute. When it's written as a percentage, instead of moving our decimal to the right, like we did to convert from a decimal to a percentage, which direction do we move the decimal to convert from a percentage back to a decimal? If we move it to the right to get to a percentage, which direction do we move it to get back to a decimal again? To the left. And if we do that here, 84.5%, move it to the left 2 spots, what do we get? 0.845, which is what we have over there. Okay? So those that said 84.5% to get that decimal in between, or that percentage in between 84 and 85%, you were correct. It's just then getting it back to that decimal value. The review, solve for n. What number plus 9 is negative 12? Raise your hand if you know. What number plus 9 is negative 12? Mia. Negative 21. Recommended way to solve that, subtract 9 from both sides. Negative 12 minus 9 is a negative 21. If you put negative 3, you went the wrong direction, right? But the reason why we subtract 9 is because it's opposite operations. Okay. The next one, what number divided by 6 is 5, Nolan? 30. The opposite of division is multiplication, right? So multiply both sides by 6, and 5 times 6, right way there. 5 times 6 equals 30. 30 divided by 6 is 5. And then a two-step equation. What'd you get for this one? 8 times what number minus 21 is 19? Josie, 40 as your value for n? You're close. When we add 21 to both sides to cancel that out, we get 8n equals 40. But that tells us what 8 n's is. We want to know what 1 n is. So what would our last step be here? If 8 n's is 40, 8 times n equals 40, what undoes multiplying? Division. So we're going to divide both sides by 8, and 40 divided by 8 is 5. Okay, so always get it all the way down to just n by itself, no coefficient in front. Okay? Final questions on this objective, because we are doing a double feature today. All right, and the next objective we're going to do is we are going to skip to CO22. And this should be CO19, not 49. Fire my editor. Okay. And the reason why we're doing this is because it's the exact opposite of what we just did, isn't it? It says recall how to convert a decimal to a percentage. Because a decimal written to the hundredths place represents a value out of 100, it also represents a percentage. Review converting from decimal to percentage with the following values. So this is like CO19 right here. 0.45 as a percentage is what? 45%. What do? We move that decimal to the right 2 spots. Huh? 45%. 0.22 as a percentage. Adrian? 22%. Move it to the right 2 spots. 22%. 0.4 as a percentage. Tristan? 40%. Move it to the right 2 spots. Throw that extra 0 in there, right? 40%. 1.36 as a percentage. Regan? 136%. Move it to the right 2 spots. And there we have it. Okay? So then to convert from a percentage to a decimal, which direction are we moving that decimal point? To the left, right? 33% to get it back to a decimal, now we're just going the other way. We're saying on our scale from 0 to 1, where's 33%? Think back to that scale that number line that we use in CO19, right? We went from 0% to 100%, 0 to 1. 33% is going to be 0.33. 21% as a decimal, move that decimal to the left 2 spots. 0.21. What would 9% be? 9%. Think of where 9% is in that number line from 0% to 100%. What decimal is that going to be, Peyton?
0.09.
Well done. 0.09. If you wrote 0.9, that's 90%. We only want 9%. So the reason why we skipped ahead a little bit here is to kind of just do the opposite of what we just did, going from percentage to decimal form. And all I want you to do for homework is this section right here. That's it. No time for review. Just that section.
Oh, all right.
Are we playing the number game tomorrow, folks?
Yes.
Please,
Better.
please, we had better. I even have 5 minutes left to work on it right now. Here's what's on your plate. Math packet number 4 is due tomorrow. Khan Academy is due on Thursday. Retakes, I'm after school today until 3, Wednesday till 3:30. Retake day on Thursday during class, and that wraps up trimester 1. All right, that's my math.